Okay, so one interesting thing that comes from oligopoly is collusion and cartels. Now, this is because there are relatively few firms, which means that there is an opportunity there for them to collude. An opportunity that doesn't really exist with perfect competition or monopolistically competitive industries, because there's so many firms, it's pretty much impossible to collude and create a cartel. But with oligopoly, there's so few firms that it becomes a possibility. But there is some conflict, right? Firms would like to collude, which means they would join a cartel or form a cartel. And the point is to collectively act as though they are a monopoly, right? Because in that way, they would collectively be able to earn higher profits. So that's the incentive to collude and join a cartel, is to act as a monopoly and together enjoy higher profits. But as it turns out, this arrangement is very often unstable. Okay, and we'll talk about why. And since it's unstable, it's actually good for consumers. The instability of this means it's difficult to actually form cartels and collude, and so the competition that ensues drives down price down below monopoly price, which turns out to be a benefit for consumers. All right, so here's a simple example, right? Two cell phone carriers in a small town, Horizon and AT Phone. Each firm has excess capacity, right? They're not producing at the minimum of average total cost. And so the marginal cost of an additional consumer, as it turns out for these firms, is basically zero, right? The cell phone towers are in place. They don't have to add any employees or additional infrastructure. They just have to have someone sign up for their service. So the marginal cost of an additional consumer is zero. Very much like natural monopolies and efficient scale. Now we want to see how the outcome under duopoly compares to the competitive and monopoly outcomes. So duopoly is just basically two firms, right? When there's only two firms. Duo. All right, so here's the cell phone market. We've got basically a demand curve, right? Price per month, number of customers, and total revenue. Here's the competitive outcome, right? Recall that the competitive outcome ends up being where price is equal to marginal cost, which is zero, and zero profit, zero total revenue. So there's the competitive outcome. And in contrast, here's the monopoly outcome, okay? This is the one that maximizes profit. So what about the duopoly outcome? What do Horizon and AT Phone do if they collude? Well, if they collude, they collectively together act as a monopoly. And so we just end up at the monopoly outcome, right? So this is the cartel outcome. It's the same as the monopoly outcome. Now we've eliminated the other ones because they basically have become irrelevant. Now, why is this outcome likely to fail? Where's the instability coming from in forming this cartel? We'll get to that. We're going to build to that. Okay, so first we need to think about something called mutual interdependence. So this is simply when the actions of one firm have an impact on the other firm, and vice versa, right? And what are the impacts? Well, the impacts are in terms of price and output. Okay, so AT Phone's response basically will depend on the action of Horizon, and vice versa. Horizon's response will depend on the actions of AT Phone. Now note the difference between interdependence and independence here. We're talking about interdependence. They depend on one another, which is different from independence, which means what I do has no effect on what you do and vice versa. That would be independence. We're talking about interdependence here, okay? Now each decision maker is going to choose the best response to what the other decision maker has chosen. And this is basically this is leading us to a concept known as Nash equilibrium. In a Nash equilibrium, each economic decision maker decides to stick with the status quo. They decide to stick with what is going on, and they don't decide to make any changes. That's what makes it an equilibrium. But it's a Nash equilibrium because of this interdependence, right? They're sticking with what's already going on, even though their actions influence one another. And so the reason they're sticking with the status quo is because there's no incentive to change what either firm is doing. All right, so let's think about a couple different cases here. First, we're going to think about the duopoly outcome, assuming that the firms choose price. So something interesting here with duopoly, the outcomes differ if they choose price as opposed to quantity. But we're going to start off with the firms choosing price. Now, we already saw that, or have talked about the fact that the cartel outcome is unstable, and it's pretty straightforward to understand why. If the two firms were able to collude and each charge a price of $90 a month and share 600 customers, 300 customers apiece, they could split that total revenue there, right? Which, by the way, is also their profit since their marginal cost is zero. I don't know why I pointed on there. That's not marginal cost, but in any case, so let's assume that's where they start, right? There's a huge incentive for one of them to undercut the other and charge $75 a month, right? Because if they did that, let's say Horizon did that, they would be able to capture all 700 customers and leave AT Phone with 0 customers, right? And so basically, Horizon would charge $75, capture all 700 customers at that price, and this would be their total revenue, and AT Phone would be left with nothing. Now, of course, AT Phone would reciprocate and charge an even lower price of $60, capture 800 customers, and earn $48,000. And the story continues, right? They keep just undercutting each other until they get to a price of 0, charging their marginal cost as the price, which, of course, I'm sure a lot of you are thinking, well, that seems unrealistic. Well, yeah, it is. They're not going to give away phone plans, right? But the idea is that they would undercut each other and to the point where they were charging a price equal to marginal cost. And since we're assuming that their marginal cost is 0, that's where the Nash equilibrium is. So that's sort of the race to the bottom scenario with if they're choosing price. But it could be that rather than choosing price, they're choosing the number of customers to serve and allowing that to determine price via the demand curve, right? So it's easiest in this case to start with what the Nash equilibrium is. So if they're choosing quantity rather than price, it turns out that the Nash equilibrium is a total number of customers of 800 at a price of $60 per month, and this would be the total revenue. So they would split this and each earn $24,000. Okay, so $24,000 is their profit. All right, so we know that a Nash equilibrium is a case where there's no incentive to change behavior, right? So let's see what would happen if, so keep in mind they're splitting this 800 customers each, so they each have 400 customers that they're serving. Now let's suppose that Horizon decided they wanted to try and serve fewer customers, restrict output in order to increase price. And so if they dropped the number of customers they served from 400 to 300, then the market as a whole would be serving 700 customers, right? AT Phone is still serving its half of 800, which is 400 customers, and Horizon drops from 400 customers to 300, so the total number of customers served in the market would be 300 for Horizon, 300 for Horizon and 400 for AT Phone for a total of 700 customers, which means that the market would support a price of $75 with that number of customers. Okay, great. So that's fine and that's all good. So Horizon rather drops from 400 to 300 customers and is able to charge $75. Well, if we figure out what $75 times 300 customers is, it turns out that that equals $22,500, which is less than the $24,000 that they were making in the Nash equilibrium. Oops, got a problem here. There we go. Right, so Horizon wouldn't want to drop its customers from this point to 300. They would earn less money. Okay. What about increasing the number of customers, right? Maybe if it increased the number of customers it served, it could be better off. So suppose it went from 400 customers to 500 customers. Well, in that case, the market would be serving 900 customers, and the market would support a price of $45. So price is $45. They're going to serve 500 customers. Let me calculate that out real quick. I didn't do that. And as it turns out, that yields the same 22,500, which again is, of course, less than 24,000. So we can see that Horizon would not want to change the status quo here from the Nash equilibrium. Okay, so interesting that we get a different outcome if they choose quantity rather than price. So this is called the Cournot duopoly. The previous one's called the Stackelberg duopoly. All right, so what we've seen is that, again, comparing our three different types, comparing duopoly to competitive markets and monopoly. Duopoly, as it turns out, charges a price somewhere between the two extremes. It serves a number of customers somewhere between the two extremes. And it turns out that it's socially efficient only when it charges the competitive market price and serves 1,200 customers. So pretty interesting, right? So yeah,